Hello, in the previous video we studied inverse trigonometric functions. We learned how to differentiate inverse functions. And today we continue that topic but with integration. Let's remind you about differentiation. We have antiderivative of psi of x is equal to 1 over square root of 1 minus x squared, right? Antiderivative of cos of x is negative 1 over square root of 1 minus x squared. And then antiderivative of tangent of x is 1 over 1 plus x squared. And antiderivative of cotangent of x is 1 with the negative over 1 plus x squared. Based on these formulas, you can write the integral of what? Dx over square root of 1 minus x squared is equal to arc psi of x plus constant. And here, dx negative in here, square root of 1 minus x squared is also arc cosine of x plus c. And here you have dx over 1 plus x squared equal to arctangent of x plus c. And of course, with the negative in here, you have 1 plus x squared equal to arc cotangent of x plus c. Here we have to pay attention. The difference between cotangent and tangent is in negative. The difference between cosine and sine here is negative. But you know, when you write like this, right? We need to understand that the domain is different. Okay, the domain of this function is different to this guy. Okay, given that two integrals are different only in the side. Okay, the same situation right here. Agree? So whatever you want, right? You may choose, write arc sine or arc cosine, but we have to understand the domain. I will not talking about cosecant and sequence. Please copy formulas for yourself. All right. So if you have some function u, right, you may use such formulas. So you may replace the x by the u. Okay, you have almost the same formula. So I will not do that. So that is kind of substitution. Okay, substitution. Let's consider the following example. We have integral of dx over 4 minus x squared. Okay, so the most important thing in this topic is you need to know how to recognize the integral formula. Because like if you have square root of 4 minus x squared, right? So you might think about the formula 1 over square root of u squared minus a squared minus u squared, right? Where a is a constant and u is a function. You see this? So if in this case, yes, you might think about arc sine. We will not talk about arc sine of what, right? Because it depends on the situation. But we need to recognize for this function, yes, we need to use the formula arc sine. Okay, and since in this formula you have square root of 1 minus x squared, right? And as I have said, we may change, right? Instead of x, if you have u squared, so you need to change that. So I need to change the function a little bit. I will change as following. I have dx, right? And here I will take 4 out. Let's say this, I take 4 out, okay? So if I take 4 out, I have square root of 4 times 1 minus x squared over 4. You see this? And in here I will have 1 over 2 because square root of 4 is 2. Dx over square root of 1 minus x over 2 square. So if you want, you can do substitution. You put x equal to, or you put u equal to x over 2, right? From here you have du is dx over 2. So if you don't have the 2 right here, you might add 2, right? Or you can solve dx equal to 2 du. And now you can rewrite your original integral in terms of u, that is 1/2. Dx is 2 du, and here I have 1 minus u squared. Okay, and now you might simplify 2 in here, and this is the standard formula already. That is arc sine of what? Of u plus c. And you substitute, your substitution back here, right? And you get arc sine of x over 2 plus c. Okay, so in this case we do a very long way. But we have the following formula. So in the future, if you see something like that, you may apply the formulas, right? You don't have to do this all the time, okay? So if you have du over square root of a square minus u square, that is arc sine of u over a. Okay, it's very easy, and you can do almost the same steps right here to get this formula. That's not that difficult. And if you compare this formula with this one, you can see in this case a is equal to 2, right? Because at the beginning you have 4 in here, right? So a is 2. You see this? And a is 2, so you just divide u by 2, so that means x by 2. That's it. This is the formula for arc sine. Similarly, you have formula for tangent. Du over a square plus u square is u is 1 over a arc tangent of u over a plus c. Okay, it's also easy. It's also easy to prove. You do almost the same thing, just do some substitution, okay? But the difference between sine and tangent is in this. In the sine, arc sine formula, you don't have this coefficient 1 over a. But in the formula for arctangent, you have 1 over a. One more formula is du over u square root of u square minus a square is 1 over a. Arc sequence of u absolute over a plus c. So we need to memorize this. Okay, copy all these formulas in the formula sheet. All right. Let's consider the following example. dx over square root of e 2x minus 1. So the function u is very strange, right? The function u in this case, you might think about u squared is equal to e to 2x, right? Or u is equal to e to the x. So you may do this substitution. Agree? If you put u equal to e to the x, you have du is ex dx. And then, what is dx? From here, you solve for dx, you get du over e to the x, right? But what is e to the x? That is u. So you have, du over u. Okay? Now you can rewrite the original integral in terms of u equal to dx is du over u, and here you have square root of u squared minus 1. And then you check the formula sheet. Yeah, it's right here, which is good, right? We have that already. So by that formula, I have 1 over a. A in this case 1. So I have 1 over 1 arc sequence of absolute of u plus c. And the u is, e to the x. So I have a sequence of e to the x plus c. Okay. Whatever you want to do, sometimes we need to do some substitution and we need to do some steps in order to get one of these formulas, that will not give us directly. Okay, so we need to work a little bit. Let's consider another example. Let's find antiderivative of x plus 2 over square root of 4 minus x squared dx. So we have fraction in this case, right? And in the denominator, we have square root of 4 minus x squared. That reminds me about, square root of what? Of a squared minus x squared. But we need to apply, the formula for this function in a good way, right? Because you check the top, you have x plus 2, you see? So that means we need to do a little bit more, not just, apply the formula directly, right? Because we don't have that. Okay, so we have x and 2 on the top. You might think about, we need to break this function into two functions. All right, so if we break this into two functions, I have x over the square root of 4 minus x squared in here, and then dx plus 2 dx over square root of 4 minus x squared. Now look at this integral. The first integral looks familiar to me. Why? Because we have the combination x dx and 4 minus x squared. You see this? X squared and x dx. We solve many problems like this in Calculus 1 and even in this course, right? The second integral looks really good to me because this is of the form we know from here. You see? We know from here. And that is about this. You see? We recognize that right away, right? We need to use arc sine for the second integral. Okay? So I write arc sine here. I try to avoid any direct writing because, sometimes we need to check formulas. So I don't remember all formulas and I don't require you to do that. Please have a formula sheet for yourself. That is the key. Okay, so let's work on each one. So I denote this by I1, I denote this by I2. Let's solve I1. I put u equal to 4 minus x squared because we have the combination dx dx and x squared, right? From here I get du equal to negative 2x dx. And we solve for x dx, that is just negative du over 2. I think I'm ready already to write I1 in new variable. I have x dx is negative du over 2 and then square root of u, right? Square root of u, which is good. That is power 1 over 2, right? So I can convert this, into power function. I write du over u 1/2. I just took negative 1/2 out of the integral because that is just coefficient. So I have negative 1/2 in here, and I use u to negative 1/2 du, right? I just bring this to the top because I want to use the power rule. I have negative 1/2. The power rule says due to negative 1/2 plus 1 over negative 1/2 plus 1 plus constant. Okay, so we have negative 1/2 u to 1/2, and here I have 1/2 plus c. We might simplify 1/2 here and 1/2 here. We have negative square root of u plus c, or negative square root of what is u? U is 4 minus x squared. Okay, 4 minus x squared plus c. So that is the first integral, you see. The second integral is, we can write the answer right away because we know the formula. That is arc sine of x over 2 plus c. Now we just, put all together. We have the original integral equal to negative square root of 4 minus x squared plus, we have 2 times over there. You see, we have 2 times in here. Okay, don't forget that. 2 times arc sine of x over 2 plus constant. And that is the final answer. Okay, so, sometimes we have to do this. Yeah, we have to break the function into, different functions, and we see how that works. We will not be lucky all the time. Let's say this, right? So we will not be lucky to see this form all the time. Okay. Now we talk about completing the square. I will tell you this. In my opinion, this is one of the most difficult techniques. Okay, because it really depends on your function, like x squared plus bx plus c. You can rewrite this as squares like this, right? X plus b over 2 squared minus b over 2 squared plus c. So I think we know this from even pre-calculus, right? This is just a parabola, right? A parabola, and if we write this, we write that expression in this form, you can find the vertex of this parabola. You see this, and even you can find the minimum or the maximum, or in this case, yeah, you can find the minimum of your function. The minimum will be attained at negative b over 2. You see this, negative b over 2, because in that case this guy is 0. So I don't think that it is something new to you, but in my experience, students just forget about about what they learned for years ago. Okay, but I tell you, this is very useful technique and not easy, not easy. Let's consider 2 examples, okay, using this technique. The first example, without any square root, so you have antiderivative of dx over x squared minus 4x plus 7. Okay, so we can rewrite this quadratic function as dx over the b in this case is negative 4, so I write x minus 2 square minus b over 2 is 2, right? So 2 square, c is 7, I have 7 right here. Okay, so it is equal to dx over x minus 2 square, and then I simplify that, I get 3. In this case, I think we are lucky in some sense, because you have the formula right away. So how do you think? What is this? This is u square plus square root 3 square, right? Which is u square plus a square. So when you see something like that, you might think about arctangent, right? Arctangent. Agree? So I applied the arctangent formula for this integral. You know, the u in here, u is x minus 2. And since you have dx equal to du, everything would be okay, right? You don't have to change. You don't have to do substitution. So you may write the solution right away. That is 1 over a, which is 1 over square root 3. Arctangent of what? Of u, which is x minus 2 over square root of 3 and plus c. Okay? So, you know, it is okay in this case, right? Because, you know, if you remember this formula, right, you can solve this real quick. But again, right, this is just one of cases you might see when you rewrite your quadratic polynomial in the form of squares. Because sometimes this value, I tell you, this value, sometimes this is negative, right? So we have to be very flexible. If this part is negative, so you will be in the case u square minus a square. You see this? But u square minus a square is even better because, you know, 1 over u square minus a square is equal to 1 over u minus a times u plus a. And you can break this function into two simple functions. How? You can write this as, you know, let's say u 1 over u minus a, okay, minus 1 over u plus a, and everything multiply with 1 over 2a. Okay, you know, if you multiply this back here, you get exactly what you need in here, right? What you need in here and in here. And we already know how to find, you know, antiderivative of this function. You see this? Because, you know, antiderivative of du over u minus a is absolute ln of absolute of u minus a. So for the other guy is, you know, du over u plus a is ln of absolute u plus a. That's it. And don't forget that you still have 1 over 2a as a coefficient. Okay, so, you know, one formula, right, in general, but it depends on the case. You may see such, you know, formulas with the u square plus a square, but at the same time, you may have this case, u square minus a square. So we have to be very flexible, okay? And don't forget, if you have this form, so you need to use this formula, okay? Let's do one more example with this, and then we will move to the last topic, comparing integrals, okay? Let's find the area of the region. About it. By the graph of f of x equal to 1 over square root of 3x minus x squared. All right, and we need the bounding here. Bounded by the graph of this guy and the x-axis, the line x equal to 3 over 2 and x equal to 9 over 4. So you might guess, yes, we need to integrate from negative 3 over 2 to 9 over 4, right? And as usual, when you see an area problem, you need to think about the graph of this function, right? The graph is above or under x-axis, or the graph has some piece under the x-axis. But in this situation, everything is above the x-axis because the function is always greater than 0. So we are good. We know the area is just equal to definite integral of the function on the given interval, right? So I can write area equal to integral from 3/2 to 9/4 dx over square root of 3x minus x squared. Okay, so that means in this case we need to change this polynomial a little bit because you have quadratic equation, right? Polynomial, right? You need to write it as in the form of squares. Let's say this. So I will do that separately. I have 3x minus x squared. This is equal to negative x squared minus 3x. Okay, so because I want to have a squared, x squared minus something, so I'll plus something. Okay, so I will use the formula right here. Where's this? This one, okay? I have x plus b over 2 minus b over 2 plus c, but c in this case is 0. b in this case is negative 3, okay? So I have x with the negative. Okay, x minus b over 2 is 3/2 plus b over 2, but we have negative. So square. Okay, and then minus 3/2 square. C is 0. Okay, so I have this, and then this is what I can write. That is actually 3/2 square minus x minus 3/2 square. I just write this back, right? All right. So my integral looks like from 3/2 to 9/4 dx over square root of 3/2 square minus x minus 3/2 square. Okay, so you can see right away what is this. That is a square minus u square and then square root. Is that correct? So what is that? That is again arc side, right? That is arc side. So I have integral from, oh no, not integral. I can write the antiderivative right away, right? And don't forget that in this case, u is x minus 3/2, and so you have the x equal to du. So you don't need to do substitution. Does that make sense? I have that is arc sine of what? Of x minus 3/2 divided by a, which is 3/2. Evaluated from 3/2 to 9/4. Okay, and you just plug this number into this function. You have arc sine of 9/4 minus 3/2 over 3/2 minus arc sine of 3/2 minus 3/2 on the top divided by 3/2. And since this guy is 0, so arc sine of 0 is 0, right? Arc sine of 0 is 0. And let's compute this. 9/4 minus 3/2 is, I think that is 3/4, right? 3/4, and then you divide by 3/2. So you get just 1/2. Okay, you get 1/2 right here. I have arc sine of 1/2, and that is pi/6. Okay, so the area of our region is pi/6. You see? So again, right? We need to write the integral, and then we'll see how that works. If our integrals look like this, so we need to rewrite this as squares, like difference of squares or sum of squares, whatever. It depends on the situation. and then we decide which one we need to use, right? In this case, we have this form, so that is arcsine. I think the last step is just computation, but of course we need to do that correctly. Okay, in order to finish this video, let's review again some integrals we consider, right, at the beginning. So at the beginning we saw this one, and this one. You see, in the first form, in the first integral, we have the combination x dx and 1 minus x squared. So we decided that we need to use substitution u equal to 1 minus x squared. Okay, but in the second integral, we don't have the combination x dx. And we see, yeah, actually we have this form, so it's familiar to us. We use arcsine of x. And here we have square root of 1 minus x squared, right? But we still have 1x in here. So we use arc sequence. Arc sequence or yes, arc sequence of x. Okay? So you know, it really depends on your integral. Okay? Another three integrals I want to show you, that is integral of dx over x ln of x. Another one is ln of x dx over x, and ln of x dx. Okay, so for the first integral, you have x and ln of x. In the second, you also have x ln of x, right? And the combination dx over x right here, and you have dx over x right here. You see that? So like the combination of x squared and x dx, for ln you also have that. When you see ln and dx over x, a good substitution would be u equal to just ln of x, because when you differentiate this, you get du equal to dx over x. You see? But for the last integral, yeah, we don't know how to do that right now. Okay, so again, right, these examples just show you we need to be flexible. We need to be flexible, and of course we need to practice a lot so that we can recognize integrals and recognize the formulas we need to use in each case. Okay, so I hope that you enjoyed the video, and this is the last video in this chapter. We will do a short review on the chapter, and then we'll write a test. All right, see you.